Okay, 5.6, the remainder and factor theorems. So we're going to determine whether a binomial is a factor of a polynomial using synthetic substitution. So this is actually very similar to stuff that we've already been working on. So we have the remainder theorem, which says if I have a polynomial and it's divided by the binomial like this, and it has a remainder, then if I substituted that value in, you would get the same answer as that remainder was. So we're going to show kind of both of these on here. So remainder theorem is going to be if I actually did the synthetic division here. So I would say I would put my 3 in the little box, just like we've been practicing. Coefficients would line up here. You would bring this down, multiply, and then add, and then multiply, and add. Okay, so this tells me that since I have a -8 remainder on here. Now if I take this function and I substitute a 3 into it, I should get that same exact answer on there. So I'm going to just substitute this right into the calculator. Oops. And I get -8 on there. So doing synthetic division gives you a remainder, and if you substitute it in, it should give you the exact same value as what you got for the remainder. So sometimes substituting it in is quicker just to see if you would get any remainder or not. If you do this and you get a remainder of 0, then that means that is a factor of that polynomial there. Just like if you do division, if I do 12 divided by 4, I have no remainder because 4 is a factor of 12. Same thing with polynomials. So example 2 says determine whether x minus 3 is a factor of this and then find the remaining factors of the polynomial. So I'm really just kind of doing synthetic division here. So again, I have a 3 in a little box. 1, 4, -15, -18. So if I do synthetic division and I get a 0 down here, that means it is a factor. If I don't get a 0, it's not. So this would be 3, 7, 21. So right there, since I have a 0 remainder, this means x minus 3 is a factor of that polynomial. So now it says find the remaining factors. So remember, this turns into a polynomial. This would be x squared plus 7x plus 6. And I want to say, can that be factored? So I look at this and say, are there two numbers that when I multiply them I get 6, when I add them I get 7? And there are. This would be 6 and 1. So I have these two factors, and then I have the original factor that we divided off. So this would be the complete factored form of this polynomial here. All right, one more. So it says the number of college students from the United States who study abroad can be modeled by this function, where x is the number of years after 1993 and s of x is the number of students in thousands. How many students can we predict will be studying abroad in the year 2020? So 2020 from 1993 is 27 years, so we're 27 years. That's what my x is going to be. So I'm going to substitute a 27 in for each of those x's in here. So we have 27 to the 4th. And then cubed. Alright, so that gives me we have 3,411 and a half students. Obviously, you can't have a half of a student that is studying abroad, but since this is just an estimation, we're just going to leave it like that. All right, so for your problems on this one, you're using the same formula there. So either using your calculator or maybe using the Desmos calculator if you need to use that. And then problem 2 is a lot like example 2 up here. So lastly, your joke. How do you get a peanut to laugh? You crack it up. All right, I hope you have a great rest of your day and make sure you're kind to someone today.